Welcome to my channel Maths by Nagabhushan. My name is L. Nagabhushanam. I have 25 years experience in teaching mathematics. You watch this video till the end. If you feel that these videos are helpful for you, then subscribe my channel and also press the bell icon to get the notifications of my latest videos. Thank you. Chapter 1 Real Numbers. In this real numbers concept, let us discuss about first natural numbers, counting numbers, that is which we use to count the objects. That is, if some chocolates are given to you, then in what way you count those chocolates? Nothing but using the numbers 1, 2, 3, 4, 5, dash, 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 like that. Use these numbers to count the objects, which are called counting numbers. Nothing but these counting numbers called natural numbers. Counting numbers are called natural numbers, which is denoted by capital N. Natural numbers denoted by capital N is equal to 1, 2, 3, 4, 5, so on. There is no end for these natural numbers. They are infinite. So we come across the situation like there is no objects. There is no objects, nothing but it is 0. So to represent that situation numerically, we have no digit in this set of natural numbers. So 0 is included in these natural numbers, nothing but called whole numbers, set of whole numbers. These whole numbers denoted by W and is equal to 0, 1, 2, 3, 4, 5, so on. Is also infinite. There is no end for set of whole numbers. Sometimes we need some negative numbers also, like temperatures in Himalayas, Nainital, like that. To represent some negative numbers are required, but this set of whole numbers does not contain any negative numbers. So negative numbers also included. That set of numbers is called integers, and set of integers denoted by the letter capital Z. Z is equal dash dash minus 3, minus 2, minus 1, includes 0 and some positive numbers. This is infinite on either sides, infinite on other sides, so that we are saying here dash dash like that, and in positive sides also this is infinite. Sometimes we come across the situations like to represent some fractions also. Let us suppose if you have a cake with you and you made into 4 parts that cake, and 3 parts you have given to your friends, and how much part, what is the part left with you, then to represent is nothing but it is 1 by 4 like that. These 1 by 4 like that fractions are not included in this set of natural numbers, whole numbers, or in these integers. So where we represent this type of numbers in fractions, nothing but we call it as rational numbers, nothing but rational numbers. These rational numbers, nothing but which are represented in the form of P by Q, which is represents in the form of P by Q, where P and Q belongs to set of integers Z, may be positive or negative numbers PQ, but Q should not be equal to 0. This is condition. So the numbers which can be written in the form of P by Q, where P comma Q belongs to integers, that is nothing but these minus numbers or positive or 0 whatever, but this denominator Q should not be equal to 0, because division with 0 is not defined. Now this every rational number P by Q can be written in the form of decimal fractions, that is decimal representation. This decimal representation, we have 3 types. Number 1 is terminating decimal. First one is terminating decimal. and second is non-terminating but repeating decimal, non-terminating but repeating, and third one is non-terminating, non-repeating, non-terminating and also non-repeating, which are in the form of P by Q, but terminating decimals and non-terminating but repeating decimals. These two types are called rational numbers. These are called rational numbers. And third type, non-terminating, non-repeating decimals. Non-terminating and non-repeating decimals. That is when we do division, like we want to write in the form of decimal representation. We cannot terminate the division as well as we cannot write as a repeating quotient. So non-terminating, non-repeating decimals called irrational numbers. Irrational numbers. So here, which are non-terminating and non-terminating but repeating. These two types of decimals are called rational numbers, whereas these non-terminating, non-repeating decimals are called irrational numbers. Now all these numbers, set of natural numbers, whole numbers, integers and rational numbers, all these nothing but belongs to real numbers. So here rational numbers plus irrational numbers, rational numbers and irrational numbers together called real numbers. Together called real numbers. So you may get doubt, are there any numbers which are not real? That is nothing but called imaginary numbers. There are imaginary numbers also. Imaginary number, with an example, just imaginary number is square root of any negative number like -1. These are called imaginary numbers. Now about the imaginary numbers you learn in higher classes, and about these irrational numbers. Irrational numbers, non-terminating, non-repeating decimals, irrational numbers we learn in next classes. Okay, here rational and irrational numbers together called real numbers. That is our today's chapter. In this chapter, real numbers, our next concept is Euclid's division lemma. So what this Euclid's division lemma states is, if you take any two positive integers a comma b, that can be written as a is equal some b into q plus r. Here q is nothing but called quotient and r is called the remainder. So is nothing but like our division rule. Let us suppose here 26 is divided by 8. So it is nothing but 8 3s are 24. So 2 is nothing but a remainder. 2 is for the remainder. Now this can be written as 26 is equal to 8 into 3 plus 2 according to our division rule. In the same way here, a is equal to 26 and b is equal to 8. These two numbers 26 and 8 can be written as 26 is equal 8 into that 3, that b into q. In this form, a is equal to bq plus r. This 26 can be written as 8 into 3 plus remainder 2. 8 3 is 24 plus 2 is 26. So 26 is equal to 26. In this way, any two positive a comma b belongs to z plus any two positive integers can be written as a is equal to b into q plus r, which is called Euclid's division lemma. In this Euclid's division lemma, Effectively, to find HCF of any two numbers of this A comma B is called Euclid's division algorithm. So, we can use this Euclid's division lemma concept to find the HCF of any two positive integers. Now, I explain this Euclid's division algorithm with one example. Let us suppose two numbers are given, 225 and 135. Two numbers are given. So, let A is equal to 25, B is equal to 135, which A comma B belongs to Z plus. So, we are supposed to find HCF. What is meant by HCF? First of all, HCF is nothing but highest common factor. So, to find HCF of these 225 and 135, what we have to do is, here I explain here first using the division method. So, here you consider now biggest number, greatest one from this given two numbers 225 and 135. So, 225 is the biggest number. Now, divide this biggest number with the smallest number, that is 135. So it goes one time, 135 ones are 135. So it is 5 minus 5 0. And here 12 minus 3 is 9, 90. Now you take this 135 to here and continue this division in this way. 90 ones are 90. So here 5, 13 minus 9 is 45. Again you continue this division. This 90 you take here as the dividend. 45 2s are 90. So where we have to stop this division is whenever you get this 0 as the remainder, then you have to stop this division. When you get this 0 remainder, whatever this divisor is there, nothing but is called HCF. Therefore, HCF of this 225 and 135 is equal to 45. I explained this process of finding HCF using this Euclid division lemma. So in this first step we can write as this one, 225 is equal to 135 into 1 plus this 90. So now this 135 can be written as 90 into 1 plus this 45. Now this 90 can be written as 45 into 2 plus here 45 to the 90 is 0. So 45 into 2 plus 0 we have to write. Where we get the 0, now this divisor 45 is the HCF of the 225 and 135 is equal to 45. So in rough side like this you can do this division and you can write these steps of this division lemma. By using this method, when you get the 0 remainder, the divisor 45 is the HCF of given two numbers 225 and 135. Now explain this finding HCF using this Euclid's division algorithm with one more example. These two numbers are a little bit big, which are given in your textbook as example. 12,576. Another number is 4,052. Okay, so here two numbers are given. One is 12,576, other is 4,052. So in this, which is greater? 12,576 is greater. So here we do this division method on right hand side. First you take this 12,576 and divide with 4,052. So it goes 3 times and here we will get 12,156. You multiply with 4052 with 3. So here our difference is 420. Now we have to take this 4052 here and goes 9 times 3780. Now here difference is 272. Again we have to carry that 420 here. Now this 420 goes 1 time, that is 272. Now here remainder is that 148 difference. Again you take that 272. Now it goes only 1 time, so 148. Here difference is now 124. Now we have to continue. I continue here. 124, 148. 1 time it goes 124. So left is here 24. Take again that 124 to here. 24 5 is 120. So 4 is the difference. Again take the 24. So 4 5 is 20. So 4 is left. Sorry, 4 6 is 24. So 0 is the remainder. When we will get like this 0 remainder, whatever this divisor is there is called the HCF. Therefore, HCF is equal to 4. Now, how to write these steps using this Euclid's division lemma? I will show that one by one. 12,576 is equal 4,052 into 3 plus here difference remainder is 420. Now this 4052 can be written as this 420 into 9 times plus 272 we got remainder. Now this 420 is equal 272 into 1 plus this 148. How can you get all these is from this division number? If you do this division right hand side, from this only you can write these steps. That is middle dividend is equal here divisor 4052 into its quotient 3 and whatever the difference we got that we write as plus remainder 420. Now next step is 4052 is equal this divisor 420 into its quotient 9 and whatever the 272 remainder. Like that, by taking this division, by observing this division on right hand side, you can write the steps of this division lemma. And 420 is 272 into 1 plus 148. Our next is 272 is equal 148. The same number here you will get 148 into 1 plus this 124. From this I am writing that one. And from 124 148 now 148 is equal here 124 times we will get 1 time plus the remainder we got there 24. Now this 124 is equal 24 that previous remainder 24 we take and 5 times it goes plus 4. Now 24 is equal 4 into 6 plus 0. Where we got the 0 remainder? Got to consider that divisor, not the quotient. Here 6 is nothing but it is a quotient and its divisor is 4. That 4 is nothing but called HCF. Therefore, HCF of this 12,576 and 4,052 is 4. So, just by taking the support of this division, you can write these steps of division lemma and you can find. For watching my videos, if you like this video and if you feel that these videos are helpful for you, then subscribe my channel, press the bell icon to get the notifications of my latest videos. Thank you.